All right, so in this video we're going to talk about Lorenz curves and the Gini coefficient. We'll start with the definition of the Lorenz curve. So a Lorenz curve models cumulative share of total income versus cumulative share of total persons. All right, so let's look at a few scenarios and look at the Lorenz curve for each of these scenarios. All right, so in scenario 1 we have 5 people and these are their incomes. Okay, so what we want to do is we want to find a curve that models cumulative share of total income versus cumulative share of total persons. Okay, so we're going to make a table out of these 5 people. There's going to be, in the first column, the cumulative share of total persons. I'll just label this persons. And then the second column is going to be the cumulative share of total income. I'll just label this one income. All right, so what we're going to do now is we're going to go from left to right through these people and figure out how many people we have each time we go over a person, and then how much income we have as we go over each person. So at the very beginning we're here, and there's going to be no persons and no income. All right, so now we're going to move over this one person, and we're going to ask how much cumulative share of total persons have we gained and how much cumulative share of total income. So we've gained one person, and there's 5 persons total. So we've gained 1 out of 5 persons by moving past this person. So we're at 20% of the persons now. And we've also gained $10,000. The total amount of income from these 5 people is $500,000. So we've gained 10 out of 500,000, which works out to be 2%, 0.02. So by moving past this one person, we've gained 20% of the people and 2% of the income. All right, let's jump over this second person here. So now we have 2 people, 2 out of the 5 people. That's 40% of the people. And we have $20,000 out of the total $500,000, and that's 4% of the income. So we're at 40% of the people and 4% of the income. And if we do this again, we'll get 60% and 60 out of 500,000, which is 12%. So now we're there, and now we jump over the 140 person. We've gained 4 out of the 5 people, so we've accumulated 80% of the people, and we're at 200,000 over 500,000 now, adding up all these incomes from 140,000 back, and that's 40% of the income. So we've gained 80% of the people and 40% of the income. And then the last person, we've gained 100% of the people and 100% of the income. So we filled out our table. So now what we're going to do is we're going to plot this data. So the first data point is 0, 0. Then we're at 2%, 4%, 12%, 40%, and then 100%. And the curve that best fits this data is called the Lorenz curve. For this set of data, it's y equals x to the 4.088. All right, let's look at another scenario. In this mini economy, everyone makes $100,000. So the total amount of income is, again, $500,000, but everyone's making the same amount. So as we go from left to right, as we move from left to right past these people, we're going to be gaining $100,000 every time. So if we draw the table and we look at persons accumulated and income accumulated, we're going to get 0 and 0 at the beginning over here. And then when we've gone 1 over, we've gained 20% of the persons and also 20% of the income. 100,000 out of 500,000 is 20%. And each time we go over, we gain 20% more of the income and 20% more of the person. So this Lorenz curve is going to be really simple. So the Lorenz curve is going to look like a curve that fits this line, and that's just going to be the line y equals x. All right, last scenario. And here we have 4 people making no money, and then the last person making $500,000. So if we do the income versus people chart here, we'll be getting 20% of the people each step as we go from left to right, and we'll be gaining 0% of the income for the first 4 steps. So 0 starts at 0, then 0, 0, 0, 0, and then as we hop past that last person, we gain all the income. So we're at 100% or 1. All right, so if we plot this, we get 0, 0, 0, 0, 0, and then 1. So our Lorenz curve is this very steep graph here. And I'll say it's y equals x to the infinity. Just a really large number we'll do here, like 10,000. Starts out super flat and then hops up to 1 as we jump over that last person. So let's go back over each of these scenarios and think about them. So this second scenario is a scenario where there's perfect equality. And the third scenario is one where there's perfect inequality. 1 person has it all and 4 persons have nothing. And then the first scenario is something in between. Somewhere between perfect inequality and equality. So what we want is we want a coefficient, a number that tells us quickly which of these scenarios we're in, or where in the middle we are if we're somewhere in between. And that special coefficient is called the Gini coefficient. So let me define the Gini coefficient. The Gini coefficient measures inequality. All right, and it's defined like so. G equals the area between y equals x and the Lorenz curve all over the area below y equals x. And the domain in each of these areas, the region, is between 0 and 1. Just like these 3 scenarios, the Lorenz curve is between 0 and 1. After 1, we're at 100%, and this curve doesn't really matter to us. All right, so let's now compute the Gini coefficient for each of these scenarios. We'll start with this last scenario. So scenario 3. We want to integrate. The upper bound is this y equals x, so x minus, and then the Lorenz curve is second, it's the lower bound. And in scenario 3, that was x to the infinity. And the denominator is the area below y equals x, so that's the integral from 0 to 1 of just x. And now we can compute the Gini coefficient for this. So x becomes x squared over 2, x to the infinity becomes x to the infinity plus 1 over infinity plus 1, and then we put 1 and 0 into that. And again, we'll get x squared over 2 with 1 and 0 at the bottom. If you put 1 at the top, you'll get 1 half minus 1 over infinity plus 1. If you put in 0, you get 0. If you put 1 and 0 into the denominator, you'll get 1 half minus 0. And then simplifying this, 1 over infinity is 0. We'll get 1 half over 1 half, which is 1. So scenario 3, this perfect inequality scenario, has a Gini of 1. This is perfect inequality. All right, let's do the next one. So we want to find the area between y equals x and this curve. So we'll get the integral from 0 to 1 of y equals x minus y equals x. And then we're dividing by the integral of x. All right, so x minus x is 0, so this numerator is 0. And the denominator is going to be x squared over 2. Put 1 and 0 into that, we'll get 0 over a half, which is still 0. So this number represents perfect equality. So perfect equality is 0 and perfect inequality is 1. Now let's look at scenario 3 to figure out where exactly between this 0 and 1 for the Gini coefficient this situation lies. All right, so we're going to do x minus x to the 4.088, and then we're going to divide by the integral of x dx. If you antiderive x, you get x squared over 2. If you antiderive this 4.088, you'll get x to the 4.088 plus 1, or more succinctly, 5.088. And then I'll be putting 1 and 0 into that. And then all I have left to do is evaluate the denominator. The denominator is going to be x squared over 2. Put 1 and 0 into that. You get a half. So we'll get a half minus 1 over 5.088 all over a half. If you put this in your calculator, you'll get 0.607. I hope you found this video useful.